Welcome to Basic Physics Learning, friend and folks. Now we are going through a very tough situation. Be healthy and keep safe. Take adequate measures. Today we will enter a very important topic of semiconductor. It's called formation of p-n junction, fabrication of p-n junction, depletion region, and total current across the junction. Please watch the video till the end, give a subscribe, thumbs up, and keep like and share, and can comment at the comment box. Let's proceed. When one side of a single crystal of a semiconductor such as germanium silicon is doped with donor impurity atom such as antimony, phosphorus, arsenic, pentavalent atom, and the other side of same crystal is doped with acceptor impurity atoms such as boron, aluminium, trivalent. In a word, impurity atoms with 5 valence electron produces n-type semiconductor by contributing extra electrons. Impurity atoms with 3 valence electron produces p-type semiconductor by creating hole or electron deficiency. It conducts well when a voltage is applied across the junction of definitive polarity, but it is non-conductive when the voltage polarity reverses across the junction. It has a definitive non-linear characteristics which we see in later. It has properties similar such as vacuum tube. Try to elaborate a little. After doping with both donor and acceptor impurities, semiconductor material left with one side large number of acceptor impurity and other side is large number of donor impurity. I mean, if someone diffuse donor impurity to a pure semiconductor so that entire sample become n-type and the acceptor impurity diffused in the higher concentration from one side to make that p-type as shown in the pictures. The fabrication of p-n junction requires a highly developed semiconductor technology. Some most important techniques are discussed. Thermal oxidation is number 1, number 2 is ground junction technique, number 3 is alloy junction technique, number 3 is epitaxial technique. To start this process, semiconductor materials available in the markets are purified by a technique known as multiple zone refining. The process depends on the fact that impurity atoms are soluble in the molten stage of semiconductor rather than solid state. To get a better view of junction fabrication, let us discuss about one of the techniques, say ground junction technique. The purified semiconductor together with calculated amount of n-type impurity, say n-type, is melted in a crucible furnace. The temperature is maintained just above the melting point. A seed crystal is just made to touch the melt and then slowly pulled out. Now new layer of n-type material are formed by freezing out the melt. Now calculated amount of p-type impurity are spread near the newly formed n-type growing crystal. After cooling out, if p-type concentration exceeds the n-type material, then the total impurity is p-type. For creating integrated circuits of silicon on wafer, you need to make pattern mask on the wafer corresponding circuitry. So, creating the silicon integrated chips and what are the distinctive advantages of thermal oxidation method are discussed. Many fabrication steps follows heating up the wafer in order to enhance the chemical process. An important example of this is thermal oxidation of silicon to form silicon oxide. This involves placing a batch of wafers in a clean silica tube which can be heated to very high temp like 800 to 1000 using a heating coil in the furnace with ceramic brick insulated liners. Then an oxygen containing gas such as oxygen itself and water flowed to the tube in atmospheric pressure and flowed out at the other end. Traditionally, horizontal furnaces are used. Now, in more recently developed vertical furnaces are employed in this process. In this process, a batch of silicon wafers is placed in the silica wafer holder is facing down to minimize particulate contamination. Then the wafers are moved into furnace. The gases flow in from the top and flow out at the bottom, providing the uniform flow than the conventional horizontal furnace. You can see the gases flow in from the top and flow out at the bottom, providing the uniform flow rather than the conventional horizontal furnace. This is a distinctive advantage. In the pictures, you can see silica wafers being loaded in the furnace. This is horizontal type. For large silica wafers, vertical furnaces are used. One of the very important reasons why silica integrated chips exist is that a stable thermal oxide can be grown on silica with excellent interface electrical property, but other semiconductor materials do not have such useful native oxide. So, in other words, why modern computer exists?
Consider an ideal PN junction. Consider an ideal PN junction. The symbol E represents the electron and symbol A is represent hole. Suppose at the formation of PN junction, electrons exceeds at the N side than the P side. I mean the electron are majority in the N side and minority at the P side. Vice versa, at the time of formation, holes are majority in the P side and holes are minority at the N side. I mean, electron density are greater at N side and hole density greater at P side. This cannot be in equilibrium situation because of difference of carrier concentration. As soon as the P region or isolated P region where the hole is majority and the isolated N region are made contact across their junctions, there are carrier concentration differences are established. In the P side, the holes are majority carrier, and in the N side, holes are minority. So, in case of diffusion is occur because the diffusion occurs when the majority concentration to minority concentration. So the hole diffuses from left side to right side, I mean P side to N side, and they leave behind immobile negatively charged acceptor ions. Similarly, in N side, the electron concentrations are greater than the P side as the electrons are majority, so the electron diffuses across the junction in P side and they leave behind positively charged donor ions. As soon as the holes crosses the junction towards the N side, they recombine with the free electron. Similarly, electron crosses the junction towards the P side, they recombine with the holes. As these recombination and diffusion process, and unneutralized ions appear in the neighborhood of the junction. The region near the junction are evacuated or depleted of free carriers. So the area near the vicinity of junction where no free charge exists, only immobile ionic charge exist, no free carrier exist, are called depletion region or space charge region. As you see, depletion of N, depletion region due to N type, as the minority of N side pluses or holes are stored here, immobile donor atoms. These are the immobile donor atoms, and this is the depletion region due to p side. It is the immobile acceptor ions. Total form the total depletion region. As we know previous, due to the diffusion, an immobile group of charges, I mean due to p side's whole diffusion, there is acceptor immobile acceptors, and due to electron diffusion, immobile donors are stored in the vicinity of junction. They are evacuated or depleted all the mobile charges. So this is the space charge region. Due to formation of this space charge, there is a electric field in the space charge regions are exist. The electric field direction is from n side to p side. I mean from positive to negative. I mean in depletion region, positive to negative. The potential is in opposite. I mean the potential exists in the n side, the potential is higher, and the p side the potential is lower, and the electric field exists from positive to negative. As we say previous, the isolated p and n junctions are made contact and they form a depletion region or a space charge region or a transition region, which is a store of immobile charges. Inside the depletion region, an electric field existed from n side to p side. So due to this, a potential barrier also existed from p to n, and the barrier is higher in the n side. Due to this, the net current across the junction is 0. So is it really total net current is 0? No. In p side, there are some majority holes who can acquire sufficient kinetic energy to overcome the barrier height to reach the n side. And in the n side, there are some electrons which have sufficient kinetic energy to overcome the barrier and to reach the p side. This is called diffusion component of hole current and electron current. Then we can talk about the drift current. Drift is the minority current. So in the p side drift, the majority is hole and minority is electrons. So when the electrons, the p side minority electrons are come near the depletion region, they will be swept out by the electric field in the n side. And in the n side, the minority holes when come near the junction, they will be swept out by the electric field in the p side. So the drift current, very small amount of drift current due to minority carrier across the junction are existed. So for the electron drift, the direction is p side to n side, electron diffusion n side to p side. Hole diffusion is p side to n side and hole drift is n side to p side. As we know, I repeat, the electric field existed in the depletion region is n side to p side. So the potential is opposite to the electric field due to this relation E equal to minus dVdx. Potential is existed from p side to n side. I mean potential is higher. So if we look at the energy band diagram, is the junction in both sides p to n. So there is energy is p side is higher and n side is lower. Conduction of hole, Fermi level for hole, valence of hole, and this is the W equal to Q0 is work done. As you see, the Fermi level is closer in the n side in the conduction band, and the Fermi level is closer in the valence band in the p side. The barrier potential is higher in the n side than that of p side because of potential and electric field related by p equal to minus dVdx. in this case, we know how exactly in the equilibrium condition the net current is 0. So in these two boxes you can understand. So in this case, you know hole is majority at the P side, so hole diffuses from P side to N side. So hole diffusion current exists from P side to N side. Hope it's clear. Then hole drift current. Hole is majority at the P side and minority at the N side. So minority holes are flows from N side to P side. So hole drift current is flows from N side to P side. So hole diffusion current is flows from P side to N side. Hole drift current is flows from N side to P side. Now look at electrons. Electrons are majority at the N side and minority at the P side. So electron diffuses from N side to P side. As we know, the direction of electron current is opposite to the flow of electron. So electron diffuses from N side to P side. So electron diffusion current is P side to N side. Now look at electron drift. Electron is minority at the P side. So electron drift from P side to N side, as the electron drift current is existed from N side to P side. So you can see at junction at equilibrium condition, due to hole and electron cancels the total current. So for holes, total current for holes, drift and diffusion cancels. So the total current across junction due to hole is 0. Total current across junction due to electron is 0. Thanks for watching the full video. You can comment, like and share and give me an advice to improve the video quality. Thanks for watching till the end.